So again we'll use this Google Collaboratory. Let me open this first. So in the last session, let me open a new notebook. Right. So in the last session, we discussed about a collection data type known as list, and we have seen the advantages of this list. Basically, in this list we can store heterogeneous elements. We can store integers, we can store floating point values, we can store strings, we can store list itself, and then it is ordered. So therefore you can access elements using the indexes. Not only positive indexes, Python supports negative indexes also, and we have seen the advantage of negative indexing. And then in Python there is another idea known as slicing. You can access a part of the list using slicing concept. So in slicing also we can use the negative indexing. You can access the last 3 elements in the list using this negative indexing along with slicing. This we have seen already. And then the other advantage of list includes it is mutable. Means you can add elements, you can delete elements, you can update existing elements, right? All these things we have seen. Different functions for adding at the end, adding in between, removing from the end using pop function, and then removing based on the element, removing based on the index. All these functions we have seen, right? So it is like dynamic. You can add everything, right? Heterogeneous elements you can add, and all these things we have seen. So in this session we will see the other collection data types. So yesterday we have seen one collection data types, list. Now we will see other collection data types. Let us say, let me write basics of Python programming 3, session 3. Okay, all right. So yesterday we discussed lists. Now we will see tuples, and then sets, then dictionaries and strings, right? List is also one collection data types. Now we will see tuples. First we will start with tuples. What is this tuple? So this tuple is similar to list that we discussed yesterday. The only difference is that once you define a tuple, right, you will not be able to change the contents inside the tuple. Unlike list, wherein you can do everything, you can update, you can add, you can delete, all these things you can do. But in tuple, once you define a tuple with 3 elements means then you are done. 3 elements only. You will not be able to update the elements, you will not be able to add elements, you will not be able to delete the elements also, right? Then you may ask, what is the need of this tuple if it doesn't support these update operations, adding operations and deleting operations? Where exactly this tuple will be useful? So it is like yesterday we have seen one function div mod, right? You see div mod of 15, 7. What do you think the result will be? The result is fixed. It is 2 and 1. Do you think it will change? Do you think it will give 3 values? No, it will return only 2 values. One quotient, one remainder. Do you think the result will change from 2 1 to some other value? No. So in these kind of applications it will return tuple. Let me show you once again. Now you will understand the result of this div mod, what exactly it will return, right? See, it was running. It will basically return a tuple. Yeah, you see 2 1. 2 1 is tuple. Actually I have not defined how a tuple looks like. A list we have seen. So anything that is between square brackets, we will say that it is a list. Now we will see about this tuple. So how to define a tuple, and then all these things we will see. So now first let us start with how to define a tuple. Let's start with defining a empty tuple. Let us say tuple. If you define in between these brackets, these parentheses, then it is like tuple. You see, let me define an empty tuple. Let me show you the type of this one. We know this function, right? Data type of variable or data structure, anything you can see. Type of T is tuple. So if you write something in between these parentheses, these brackets, then it is tuple. If you write something in between square brackets, then that is list, right? So all right, we will define some tuple, right? Okay, let us say T equals to in between these brackets, let me define 23, 45, 45, 66. Let me show you what exactly is there in this tuple. And then yesterday I forgot to tell you about help. Suppose you wanted to know about all the functions that are supported by some variable or some data structure, let us say data type. Then you can write T question mark, then press enter. It will give you the help about this T. You see, this will give you help. You see here, type of T is tuple. What it contains? It contains 23, 45, 66. What is the length? Length is 3. Built is a, you see here, built-in immutable sequence. Since it is immutable, immutable means what? You will not be able to add elements, delete elements and update elements. It is fixed. Its length is 3, its elements are also fixed, 23, 45, 66. If you want to define a new tuple, that is okay. But if you wanted to update this tuple, that is not possible because it is immutable. Whereas list is mutable. Okay, that is the difference between list and tuple. That is mutable, this is immutable. Okay, and see, you see the help here. If no argument is given, it returns a empty tuple, right? If iterable means these values. If iterable is specified, then tuple is initialized from iterable items. You see, these are the iterables I was telling. If you give some items, then list will be initialized with those items. That's what it was telling. So this was giving help about this T. T, not only T, anything you can give. Suppose you wanted to know all the functions that can be applied on this tuple, then there is a function called dirt. You write dirt and run it. You see, these are the functions that can be applied on tuple. Count and index. Only two functions are available with tuple. Let me define a list and let me show you the functions that are available with list. Let us say list. Let me give L rather than writing a list. List equals to, let me give something 3, 5, 8, or 3, 6, 8, 13, 56. Let us say. Let me define this one. And let me show you what are the methods that are available with list. You see here, these are the list of methods that are available. Append we have seen yesterday. Append will add at the end. Clear we have not seen, not necessary. Count. Extend we have seen, index we have seen, insert we have seen, pop we have seen, remove we have explored, reverse we have explored yesterday, sort we have explored yesterday. If something I have not covered, you can explore those functions also, like what I have not covered, count. Let us, okay, since tuple also supports count, let me explain this count here. The same way count works in list also. So this way you will know the list of functions that are available with some variable or some data type. This way you can use dir of that particular name. Whereas the other one is this will give you help about that particular data type or particular variable or whatever it may be, list or tuple. Okay. So this is about help and all these things. So basically tuple only supports two functions. One is count, the other one is index, right? Count and index. So now we'll see this count, how exactly this count will work, how exactly this tuple will work. So before going to discuss about these functions, okay, now let me give one more detail about this tuple or list. So there is a function or keyword, you can say, tuple. This is inbuilt function again, tuple. If you give some list as input, let us say 1, 2, 3, 4. This is a list because you see it was enclosed in square brackets. Now the moment you call with tuple, what it will become? It will convert the input to tuple. Okay, let me run it and let us see the result. Name tuple is not defined. It is not capital T, small t actually. You see what I have given? I have given input as list, but you see the output is a tuple. Similarly, for list there is a function called list directly. Let me pass a tuple as input 1, 2, 3, 4. Now you see what is the output. You see it will convert into a list. So this is like for converting from other data types to tuple. This is for converting from other data types to list. Now, okay, now let us see the functions, inbuilt functions that are supported by this tuple. It supports only two functions. One is count, the other one is index. So what is this count? So tuple, where I have defined tuple, this t, where is this one? Alright, let me define one more tuple here. T equals to, let me directly write 1, 1, 3, 5, 8, 1. Okay, this is the tuple. Let me show you what is there in this T also. This is the, now what count will do? It is self-explanatory. T dot count of some element you give. Let me give 1. What it will give? How many times this element 1 is present in this particular tuple. Same way, this count function can be applied on list also. It will count number of times the element appears in the tuple or list, right? So same way, the next function is index. Only two functions are supported by, two built-in functions are supported by this tuple because it is immutable. Index function. So what this index function will do? If you give index of 1, what it will do? It will return the index. Index means it will return the position where exactly this element is present in the tuple. So since the element 1 is there at 3 locations, right? So therefore what it will return? It will return the first position in which this 1 appears. So you see 1 appears at the 0th position. Now the moment you change from 1 to 5, let us say 5. You see 5 appears at index 3 because index starts from 0. 0, 1, 2, 3. So I hope these functions are clear, count and index. Since it is immutable, only these two functions are supported. But so this is the only difference. This is immutable, list is mutable. Now you may ask, what about other one? Is it ordered? Yes, it is ordered. So you can access elements using index. Now if I give t of 2, element at second index. Element at second index means what? 0, 1, 2. It is returning 3. So there is a ordering. There is a ordering between these elements, right? So second element means 3, third element means 5. So you can give some ordering between elements. So this is the order of elements. So same in list also it is ordered. That's why we used indexing. So since it is ordered, you can use slicing also here. Slicing we know, right? So let me access a subpart of this tuple. Subpart means, okay, let me give from 1 to 5. Let me give 5. 5 means it will go up to 4. You know, right? 1, 2, 3, 4. But it will not include 5. So this is the element at first index. This is the element at second index. Element at third index. Element at fourth index. You see. So it supports indexing and slicing. That means tuple is ordered. There is ordering between these elements. List is also ordered. That's why we used indexing and slicing. Alright. And it supports duplicate elements. You see. Duplicate elements can be present in the tuple. Same as list. List also supports duplicate elements. Okay, so with this I will close this tuple because there are not many built-in functions that are supported by this tuple. With this I will close tuple and then I will move on to other collection data types. Collection data type. Next collection data type I will cover is sets. Okay. So sets. So most of you are aware of sets. Mathematical people, they use very frequently this idea of sets, right? And you know, now if you compare sets with tuples and sets with lists, basically sets does not support duplicate elements, right? If you add duplicate elements, it will simply throw an error because these are sets. Duplicate elements will not be supported. Now we'll see how to define a set, then we'll see the features of this set. So if you want to define some set, use this inbuilt function set and you give the input 1, 2, 3, 4, 5, let us say. You see, it was there inside curly braces. But how to define a set? We have to use this function, set function, and you give input. Now let me define one more function, one more set. Okay. 1, 2, 3, 3, 5. Now what do you think the result will be? The result will be 1, 2, 3, 5 because it will not have means what duplicate elements. Even though you gave duplicate elements will be removed and then the result will be written as a set, right? Now we'll see the built-in functions that are supported by this set. So before showing built-in functions, let me first show you what are the built-in functions that are supported by this particular collection data type set. Okay, I have not saved anywhere. Let me save this. Otherwise, let me define one more set here. S1 1 3 5 7 7 8 1 4 99 45. Let us say this is one set. Let me define second set. Second set, let me define 1 3 77 88 33 44 7 8 37. These are the two sets. Now if you wanted to see the set of functions that are supported by set, what is the function? I already described, dir of S1. You see, it will show you the functions that are supported by this particular one. Append. So that means what? This itself will say that set is mutable. You can add elements. Clear copy, okay. Count, you can count the elements. Extend is there. Index, insert, right? You can add means you can add elements. Pop is there, remove is there. That means you can remove elements from a set. So that means what? Basically, it is mutable. But we will see what up to what extent it is mutable. Okay, it supports adding elements, it supports deleting elements, but we will see. So basically, set is unordered. Unordered means what? If you wanted to, there is no ordering between these elements. There is no ordering. No ordering. Okay, this is what? Oh, these. Okay, this is list. Okay. Okay, this is list. Sorry. First, let me convert this into set. Okay. Let me give L1 and L2. There is no need. These are lists. So let me directly convert these things into sets. This is list, right? Let me convert into, let me use S only, S1, S2, let me use small only. Okay, now we will see the functions that are supported by list, this set S1. Now you see, these are the functions that are supported. S, it supports appending, right? It supports, okay, did I run this one first of all? Now let me run this one. Yeah, these are the functions. Yeah, that's why it was not showing the clear things. These are the actual functions. First of all, we have to run this one. Then only S1 and S2 are sets. Now I am showing the list of functions that are supported by this particular set. Now if you see add, using add you can add elements. I will demonstrate. Using pop and remove, you can remove elements, right? So that means this is mutable. First of all, it is mutable. So it is mutable. Set is mutable, but it doesn't support ordering. So if you wanted to access some individual elements, like let us say S1 and S2 is there. Let me show you what is there in S1. Let me show you what is there in S1. This is there in S1. Now if you wanted to access first element using index, let us say S1 at third index, it will, you see, object is not subscriptable. That means what? It doesn't support indexing. So basically it is unordered. There is no ordering between these elements. That's why it is not supporting this indexing. So it basically shows that set is unordered. Okay. Okay, let's discuss some other functions. First we'll see. So since these are sets, it supports many set operations. Suppose if you want to perform union, S1 union, S1 union, S2. This is the union, right? Duplicates it will remove. Similarly, it supports intersection, S1 intersection, S2. This is the intersection. Similarly, difference, set difference, S1 difference, S2. S1 dot difference of S2, that's all. It is running. Similarly, if you want to run S2 dot difference of S2, this is S1 minus S2, S2 minus S1. This is S1 minus S2, this is S2 minus S1. Now, you wanted to find S1 minus S2 union S2 minus S1. How to find that one? That also you can do. How to find? That is symmetric difference. S1. Okay, that we'll see. So first we'll see how to, okay, otherwise. So similarly it supports S1 is subset of S2. So it will tell whether it will return true or false. If S1 is subset of S2, then it will return true, otherwise it is false. Since S2 is not a subset of S1, where is S1 and S2? This is S1. You see, S2, is it a subset of S1? No. So that's why it returned false. Similarly, you can check whether S1 is superset of S1. S1 is superset of S2. The other way also you can check. Similarly, you can check whether the sets are disjoint or not. Is disjoint, you see. Whether S1 and S2 are disjoint. No, there are some common elements, right? We have seen the intersection. Intersection is not empty, so therefore they are not disjoint. So this way, there are many other functions. Okay, let me show you in directory of S1. Other functions also. You see, okay, difference update, intersection, disjoint, subset, superset, symmetric difference, union. We have seen. So like this symmetric difference. What is this symmetric difference? S1 minus S2 union S2 minus S1. So you simply call S1 symmetric difference S2. It will return S1 minus S2 union S2 minus S1. S1 minus S2 is what? 4, 5, 45, 99. S2 minus S1 is what? 33, 44, 77, 88. 4, 5, 33, 44, 45, 77, 88, 99. Okay. Now we will see how to add elements. Because it is mutable, you can add elements. How to add element? There is a function called add. First let me print, then I will show you the result after adding. S1 dot add. Let us say, let me add some 55. 55 is not there. Okay. Now let me show where is this S1. What is this S1? Now you see where the S1 was added. It was added here somewhere. So basically set is unadded, right? That's what we said. So this since there is no ordering, there is no concept of ending, beginning, middle, right? There is no ordering. Then where exactly this ending, in between, these concepts will come. There is nothing like adding at the end. So here we are adding. So it will randomly add. It will add somewhere in the list. That's all. This is the add function, right? Similarly, now if you want to remove, there is this function called pop. Now which element it will remove? You see, it has removed an arbitrary element, not necessarily the first element. Now let me again pop it. Let me apply the pop function. 3 was removed. Okay, but there is no ordering. It will It will arbitrarily remove an element from the list. This pop function. But if you want to remove a particular element with the name, there is no index, so you will not be able to remove elements based on index. But if you wanted to remove based on element, suppose I wanted to remove 55, then you can remove using this remove function. You have to pass the element. Similarly, let me show you. So S1 I will show you after removing this one 55. 55 was removed, now you see. So same way, clear, it supports a function called clear. What this clear will do, it will clear the list. Okay. Clearing means what? Now you see what do you mean by clearing? Clearing means the set, all the elements in the set will be removed. So the same function and the same explanation is valid in list and list also. In list also, if you wanted to remove all the elements, you simply call the function clear. Alright. So this is about sets. So it is unordered, but it is mutable. Right? You can add elements, you can delete elements, but it is unordered. There is no indexing, there is no slicing. And it does not support duplicate. It does not support means even if you give duplicate elements also, duplicate elements will be removed. That's the definition of basic definition of set, right? So this is the collection data type set. So now we'll see other collection data type. One more collection data types. Let us say string. String is also a collection data type. Okay, let me write here string. Now string. So string is basically ordered. So the moment I said ordered, it supports indexing, it supports slicing also. Basically string means, you know, it is some sequence of symbols that can be stored inside some variable, right? So now there are three formats that are available in Python for defining strings. So if you want to define a single character, then it is better to use, okay, let me define string 1. If you wanted to store a single character, then the character should be enclosed in a single quote. Let us say A. If you wanted to define a string with sequence of characters, then you can use double quotes, Bala. And then the third one is string 3. If you wanted to define a paragraph, then you can go for triple quotes. So the string should be enclosed in triple quotes. So let me write something in between triple quotes. Ramanujan College refresher course. Now you can see what is there in string 1, what is there in string 2, all these things. String 3. See Ramanujan College, it is new line, refresher course, and so on, right? Now, suppose you want to define this using double quotes. What happens? You see now, rather than triple quotes, I want to define it using double quotes. It will return an error saying that it is expecting an end of this particular literal at the end of the line, but it was not found, so the error is here in this line. See, end of the line while scanning string literal. This is one of the string literal. Single quote, double quote, and triple quotes. These are string literals. So when you are writing something that spans across multiple lines like paragraph, use triple quotes, right? So same way you can see the list of functions that are available with string using DAR of, let us say, string 2. Let me give string 2. Let me show you. These are the, you see, capitalize, center, count, encode, ends with. You can explore all these functions. So I hope strings are not very useful for you people. That's why I'm not covering full details about strings, but I'll cover some functions, some 2-3 functions at least. So it supports slicing, it supports indexing. So let us say string of 2. So what is the character at second location? String 2. This is basically string 2. String is not defined. This is the character at second location, BALA, right? Second, where is the string 2? This is string 2, BALA, 0, 1, 2, right? Now same way it supports slicing also. Slicing means what? Let us say 1 to 4. Oh, string is not defined. This is the problem at the time I'm facing. ALA, right? Now let me define one more string. Let us say small s. Ramanujan College. Ramanujan College. Now suppose you wanted to capitalize each first letter of each word. Then there is a function called capitalize, right? S1 dot capitalize, called S1 dot capitalize. You see, first letter of each word is capitalized using this function. Similarly, if you want to convert everything into capital, there is a function called upper. You can convert the entire string into uppercase letters. Same way, if you want to convert something into lowercase, you can convert everything. It is already in lowercase. Let me store this somewhere, then let me show you this S1. This is uppercase. What is there in S1? It is uppercase. Now S1 dot lower, it will give you lowercase. So this way it supports many other functions, but I am not exploring all the functions for strings, right? So now, so this is about strings. So you can explore more details about strings using the help. Now let me go and discuss the other collection data type called dictionary. Okay, now, so dictionaries, we'll see these dictionaries. What is these dictionaries? So dictionaries is like database. If you wanted to store database kind of things, then these dictionaries are very useful. So what is this database? Database means what? You have some record, right? So as I hope most of you are aware of this databases, the structure of databases. So you have a set of records. Each record can be accessed uniquely by a key. Using key, you can access the content of the record. Let us say entire record can be accessed using a key, right? So basically, this dictionary is like a database with key value pairs. If you wanted to store key value pairs, then this particular dictionary is a suitable data type for storing key value pairs. Key value pairs means what? You wanted to store some records and you wanted to access those records using some key. Then dictionary is a suitable data type. Now first let us see how to define a dictionary. So anything that is between these curly braces is dictionary. Means if you are this is while defining. For set, you see I have already described about sets. Sets, we are only using this function. We are just converting. But tuples, we are using this one. List, we are using square brackets. But for sets, we are not using this one. For sets, we are using the function directly. Whereas for dictionaries, suppose you wanted to define an empty dictionary, you can directly define like this. Now let us see what is the type of D. Type of D is dictionary. Don't confuse this with set, because I have defined a set S1 equals to set of 1, 2, 3, 4. Let us say I have defined like this. And what is there in S1? It was there between curly braces. So don't confuse this with this. While defining, if you give curly braces, then it is dictionary. Okay. But while defining set, you have to use this particular function set. This kind of syntax is not allowed. So now, if you wanted to define some dictionary, let us say D1 with some values, you can directly write like this with curly braces. But the structure is different. What is the structure? It should have two things. One is key and the other is value. Key value pairs you have to write inside the dictionary. Key value pairs means what? Let me store my record inside this dictionary. Let us say name, my name, let us say. Let me store in string only, Bala. college, NITW, let us say phone number, 1 2 3 4 5 6 7 8 9, let us say age, let us say age something some randomly 6 7, then let me store 32 age this way, then you can store whatever you want, okay, like this information. So now this is a dictionary, let me, that is enough, okay. Now let us see what is there in D1. So now if you wanted to access the values, you give D1 of, I wanted to know the name, D1 of name. Using key you can access the value, right? If you wanted to access D1 of, let us say phone number, 1 2 3 4 5 6 7 8 9. So using keys you can access, using the keys you can access the value, right? Now what if I give something like this, indexing D1 of 1, D1 of 1, this is giving error because there is no key 1. What are the keys here? So at this time I wanted to show you. So if you wanted to see all the keys inside dictionary, there is a function called d1.keys, simply called d1.keys. These are the keys, list of keys, name, college, phone number, age. If you wanted to see all values inside dictionary, call this function d1.values, not value, d1.values. Now if you wanted to see all the items, item means what? Key value pairs, all key value pairs inside dictionary, this way. You see, this is the first item, this is the second item, this is the third item, this is the fourth item. Now you see all these items are what? Tuples. These are tuples, right? And then it has returned as a, you see, dictionary items, all are tuples. So I hope it is clear, this one. So you can use dir function to get list of what functions that are supported by a dictionary. Now suppose let us say okay, that I leave. I will discuss how to know the built-in functions that are supported by dictionary. So you can see dir of d1, it will describe the list of functions that are supported by dictionary. So if you see here, see items we have seen, d1.items, d1.keys, d1.values, these things we have seen. d1.pop is there, but how to add new element? Now this is the question, right? Pop you can remove using this pop, but how to add? That is the question. These are there. Clear, you know, clear, right? And then others are okay. Values. Okay, now let me see how to delete an element. d1.pop. If you simply give pop, what happens? It will give an error because you have to, it is expecting at least one argument. Why? Because you have to pass the key. So let me remove the name, then it will work. Name was removed. Now you see what is there in D1. Name was removed. You see age, college and phone number was there. Name was removed. Now, okay, using pop you have to supply the key, then you can remove the item. That is okay, alright. But how to add elements now? So if you want to add some element to the dictionary, Suppose you try giving like this, d1 of name, let me give now, d1 of name is equals to something, Bala. What happens now, we'll see, we'll run. Now what is there in d1? You see, name was added. Can you see? Now name was added using this one. So you can add a name, you can add a new new item into dictionary this way. Suppose if you wanted to add location, let us say d1 dot location, let me give Warangal. This way you can add. So we are able to, you see, this is the dictionary. A is 32, college, then name, Bala, phone number, this one, location, this one. So we were able to add new items into the dictionary. We were able to remove items from the dictionary. Now what about updating, we'll see. So can we, this location we'll try to update. Then we'll know whether it supports updating operation or not. Location, I'm changing from Vizag to Visakhapatnam, let us say. Visakhapatnam. You see, location was changed, right? So we were able to add elements, we were able to remove elements, and we were able to update values using keys. We are able to update values. Now what happens if I try to add duplicate key? This way, duplicate keys, can you add duplicate keys? Now let us define a new dictionary to add duplicate keys. Let us say A, let us say 1. Now let me add A again, let me give 2. What is there in D2? A2. I have defined 2 things, you see. Key, let me define 3 things otherwise now. B, 2. Can you see this one? So it does not support duplicate keys because key will uniquely identify a record, right? That is the idea of key. So key should be unique. That's why it will not allow duplicate keys. Since I have given 2 keys here, A with 1, A with 2, it is only taking the last one, A with 2 and then B with 2. So duplicate keys are not allowed, but duplicate values, we'll see now. Duplicate values, will it allow duplicate values? C with, duplicate values are allowed, you see, A with 2, B with 2, that is okay. But duplicate keys are not allowed. So here I will stop about this collection data types. So in collection data types from session 2 and session 3, we have discussed lists, tuple, sets, strings and dictionary. List is ordered, mutable, you can add elements, you can delete elements, you can update elements. It supports heterogeneous elements, that is okay. Ordered, mutable, duplicates are allowed. Whereas tuple is fixed, static, and the other advantage of list is it is dynamic. Tuple is static, length cannot be changed, elements are also, elements we are not able to change elements also, we are not able to add elements, delete elements, update elements. It is immutable, fixed length, fixed elements, but it is ordered, it supports order. Then sets, no order, duplicates are allowed, but it is immutable, you can add elements, you can delete elements. String, it is ordered, indexing is supported, slicing is supported, right? Dictionary, key value pairs, keys should not, there should not be any duplicate keys. Values, we can have duplicates, right? You can add elements, you can delete elements, you can update elements. This we have seen. So this concludes this collection data types. And the last point I wanted to add is anything that is between square brackets, it is list. Anything that is between, means while defining something, you wanted to define something, you wanted to give some values to some variable. If you write the data inside square brackets, then it is list. If you write the data inside curly braces, this curly braces, then it is dictionary. If you write something inside these parentheses, these brackets, then it is tuple, right? All right. So here I will stop this collection data types.